Okay, here come the last subtopic, which is 4.4, roots and zeros of polynomial. Okay, in this subtopic, you should be able to find the roots and the zeros of a polynomial, and also you should be able to determine the complex zeros of a polynomial up to 3 degree. Okay. So let's see some new definitions. Okay, a zero of a polynomial px is a number a such that pa equal to 0. So previously we have learned about remainder theorem, Rx. So the polynomial must be equal to 0, and then the previous subtopic, the third subtopic, which is what we call that, remainder and also factor theorem. Yes, factor theorem. So you have x minus a is the factor. Okay, and for this last subtopic, we have a zero of polynomial, meaning that a zero means a number which is given by a. So when you substitute this number a into the polynomial, you will get 0. And then x equal to a is called a root of the polynomial of equation px equal to 0. Actually, all those terms, remainder, factor, 0, and also root, they revolve around the same things. Okay, sebenarnya keempat-empat tu berkisar pada satu yang sama lah, yang polynomial. You boleh find factor from the remainder, you boleh find zero from the factor theorem, you can find root from the zero, macam tu. Okay, they are all related. Okay, in general, if x equal to a is a root of a polynomial equation px equal to 0, then x minus a is a factor of px. See, this is what I mean just now. They are all related. Semuanya berhubung kait. Kalau kita tulis dalam bentuk persamaan x equal to a, this is known as a root. But when we call it as a saja, that is a 0. But when you write it down using bracket like this, x minus a, it become a factor. Okay, and every polynomial equation of degree n has exactly n roots. Some of these roots may be repeated. Okay, senang cerita. Dia kata dekat sini, untuk setiap polynomial equation dengan degree n, kita akan dapat n roots juga. Contoh, kuadratik. Kuadratik kan dia punya degree x square kuasa 2. Maksudnya you akan ada 2 roots juga. So, dia samalah. If you have n degree, then you will have n roots. If you have 2 degrees, then you have 2 roots. If you have cubic kuasa 3, you will have 3 roots. Macam tu. Okay, example. Show that negative 4 is a 0. So, 0 is actually one number dalam sebutan nombor. Show that negative 4 is a 0 of this polynomial. So how are we going to prove, how are we going to show it is actually a 0 for this polynomial, is that we're going to substitute this negative 4 into this polynomial. So you will have p negative 4. You substitute into this whole thing, this polynomial, 6 times negative 4, cube plus 2, 23 times negative 4 square plus so on. Then you key in into your calculator, you will get the answer is 0. So we can say that since p negative 4 equal to 0, then it is proven that negative 4 is a 0 for this polynomial. Okay, as long as you substitute into the polynomial, you get 0, meaning that this number is a 0. But if it asks find the factor, so you have to factor. How are we going to write down a factor? So a factor going to be in a bracket. Factor kan? So this is 0. Kalau factor, dia become x plus 4. So it's become, I'm sorry. if the question asks you to find a factor, then it becomes x plus 4 is your factor. Okay. And if it asks you to find what else? 0, factor, and roots. Find the roots. Okay, so the root will be x equal to negative 4. So that is the roots. Okay. So from this one term, So from this one term 0, you can actually generate lots more information. For example, you can find the factor, you can find the root. Okay. So I hope you can get all these three terms correctly. Okay, let's move on to more example. Find the roots. Okay, now you have to find roots. Roots meaning it's in term of x equal to something. Okay, find the roots for the equation this one. And can you see over here? It's equal to 0. Okay, so px equal to, so we let this as our polynomial, px equal to x cubed plus 3x squared plus x minus 1 without the 0. Okay, so now you have to by trial and error, cuba jaya, kaedah cuba jaya, you first want to let your the x equal to 1. Kita cuba jaya. We try it with 1. So you substitute 1 into this equation, but unfortunately you get the answer not equal to 0. So 1 is not going to be your root. Okay? So we try, if 1 not going to be your root, how about we try negative 1? So when we try negative 1 and we substitute into this equation, you get the answer equal to 0. So meaning that we can say that x equal to negative 1 is the root. Okay, so we can say that x equal to negative 1 is the root. And the factor will be, this is the factor, x plus 1. Bila kita bawa pindah ke situ, dia jadi x plus 1. Ingat, the term in the bracket is always a factor. Kalau yang dalam tulisan dalam bentuk bracket ni, itu adalah factor. Kalau guna persamaan macam ni, dia adalah root. Kalau dalam bentuk nombor sahaja macam ni, 1 negative 1 itu adalah 0. Okay. So you have x plus 1 is one of the factor daripada sini kan? So we know this, bila kita substitute equal to 0, remember the factor theorem, kalau kita substitute equal to 0, meaning that is the factor. X plus 1 is our factor. Why do we need this factor? Is because we're going to perform a long division so that you can find the other roots. Because this equation, the degree is 3. The degree is 3, meaning your roots, you will have 3 roots. You will have 3 roots or 3 factor and 3 zeros. Sebab berkadaran. Okay, it's berkadar secara langsung, proportionally dengan you punya n over here, n degree. So now you only have one. You only have one factor, one root. You need to find the other 2. So how are we going to find the other 2 is using this as your dx, your divisor. We're going to let this as our divisor and we're going to divide this whole thing by this. We perform a long division. Guna yang tadi yang kita jumpa one factor kan? So we perform a long division. X time berapa dapat x cube? X time x square. So you get x cube. So letak minus dekat sini lah. And then yang belum disentuh ni, kita multiply dia dengan x square. 1 times x square, you get x square. So we minus this thing, you have 2x square. This thing bawa turun. So again, we start again. X time berapa dapat 2x square? X time 2x. So you get 2x square. And this 1 multiply with 2x, you get 2x. So you minus this thing, you get negative x. This thing bawa turun. Okay. So negative 1. So again, x times berapa? Dapat negative x. X times negative 1. So you get negative x. And this, dia punya yang belum sentuh ni boleh multiply with this. 1 times negative 1, you get negative 1. So again, we minus these two, you get nil. So the remainder is 0. Okay. Terbukti dia punya remainder 0 sebab this is one of the factor. So now you have this quotient. So you have 1. From here, you can factorize. Ni kita dah dapat 1. 1. Kita dah dapat 1. The other 2 is coming from here. You will have another 2 roots. You have 2 roots or factors. You will have another 2 roots and factors over here. Sini you have another 1 root or factor. Okay. Again. So, you have 1, 2, and 3. So, it's enough. Betul lah. You akan dapat 3 factor, 3 roots, and 3 0 because of this is cubic, kuasa 3. So, how are we going to get x plus 1 equal to 0, and the other one will be x squared plus 2x minus 1 equal to 0. But if you can factorize, if you have x squared quadratic, first you want to factorize. But in this case, this equation, quadratic equation, cannot be factorized. So you need to use the other form, factorization using formula. Negative b plus or minus b squared minus 4ac divided by b. So you have to check back your chapter 2, quadratic equation. Okay. So you just plug in the value. What is your negative b? What is your b? B squared, 4a, and c. Okay. So this is a. This is b. This is c. Okay. You substitute into this thing. This is actually a formula quadratic tu yang x equal to negative b plus minus b square minus 4ac. Kan square root. Then you divide by b. Check back your chapter quadratic punya formula. So you get 1 is this one. The other one is this one. Okay. So you have all three. 1, 2, and 3. Negative 1 plus square root 2 or negative 1 minus square root 2. So you have 3 roots. Remember roots ni dalam bentuk equation. Dia punya sebutan ada equal sign ni. X sama dengan berapa X sama dengan sekian, sekian, sekian. But for factor selalunya ditulis dalam bentuk macam ni. Yang ada bracket. Okay. And 0 pula adalah number itu sendiri. So you don't get confused, ya. Okay, more example. Determine all the roots of x to the power of 4, blah, blah, blah. Okay, so you need to find all the roots over here. Roots meaning dalam sebutan nombor. Okay. So by inspection, maksudnya by inspection ni kita tengok, we try using trial and error lah. So trial and error mean you cuba jaya. You try 1, you try 2, or negative 1, or negative 2, whatever lah you want to try. So of course first of all we want to try with 1 or negative 1. That one is very basic to start with. So P1, you substitute 1 into here, so you get 0. Okay, done. And then we try pula P negative 1. You substitute into this. Okay, nicely we get also 0. So we can say that we already obtained 2 factor, x equal to negative 1 and x negative 1 and x plus 1 are factors of px. So kita punya we can say that we have 2 factor, 2 roots already over here and 2 zeros. Okay, but now, adakah dia cukup? Adakah 2 tu cukup untuk this polynomial yang kuasa 4? Tidak. Kenapa tidak? Because this is kuasa 4. But yet you still have, you only have 2 factors. So you need to find another 2 factors, okay, to complete this kind of polynomial. So what happens is that you're going to write it down nicely macam tadi. So you have factor x minus 1 and x plus 1, and then we don't know the other factor, which is ax square plus bx plus c. So we assume lah dia ni dalam sebutan ax square plus bx plus c. So your task is that you're going to find what is a, what is b, and what is c. Okay. So, okay, yang untuk kedua-dua ni kalau kita expand, you will have x square minus 1, kan? Ni bila you expand 2 ni, you get this one. So, bila dah dapat macam ni, what I'm going to do next is I'm going to perform this one. I'm going to compare the coefficients. Okay? So, I have, for this one, expand dia. Expand, kembangkan dia. Expand dia. Please expand it. Expand these two. X square times ax square, you get ax to the power of 4, macam tu kan? So you dapat ax to the power of 4 and so on and so forth lah. Inilah yang after we expand. This one is after we expand. So we compare with the polynomial, original polynomial just now, px, yang ni. This one, original px, kita punya px. This one yang you dah expand tadi. So you compare kiri dan kanan. Untuk sebutan x to the power of 4, x to the power of 4, sebelah sini ada 1. Sebelah sini ada a, meaning that a equal to 1. And now we're going to compare about yang kuasa 3. Sebelah sini x kuasa 3, the coefficient is 1. But for here, the x kuasa 3, the coefficient is b. So we can say that b equal to 1 also. And for x square, kuasa 2, the coefficient is negative 7. Okay? Negative 7. So, you cari pula dekat sini, coefficient dia adalah c minus a. So, you boleh carilah c minus a equal to negative 7. Ni macam ni dia actually. Negative 7 equal to c minus a. Your a is 1 kan just now? So you're going to find your c is actually negative 6. That's why this is how you obtain your negative 6. Okay? And the 6 over here constant. So you already have everything. A, B, and C. You found it all. Okay? Therefore, kita tulis semula yang tadi tu. Yang ini yang ada sebutan A, X square, BX plus C. Kita tulis semula nicely. We write it down nicely. X minus 1, X plus 1. So this is AX plus B plus C. Okay? From here. AX square plus BX plus C. This is actually AX square plus BX plus C. This is actually the one previously. Okay. And this x square plus x minus 6, you boleh factorize dia. Sebab dia kuasa 2 kan? So you can, when you factorize it, you will get x plus 3 and x minus 2. So you will get these two. So now, all together, you have 1, 2, 3, and 4 factors. So, adakah dia, is it satisfied? Is it sufficient for your polynomial? Yes, because this polynomial is cubic. Okay, you have power of degree of 4. So now you have 4 factors. Cukup. Then we can say that if px equal to 0, then x minus 1, x plus 1, and so on and so forth must be equal to 0. So the roots, you ambil balik yang daripada sini. Roots ni cuma you tulis dalam bentuk ada equal sign. X equal to 1, X equal to negative 1, X equal to negative 3, X equal to 2. So inilah dia. Okay. Okay, I'm sorry. We have another one. X equal to 1. So you have 4. Okay, that's it. Okay, note that when attempting to factorize a polynomial of degree 4, macam yang tadi kan, degree dia kuasa 4, it is necessary to find two linear factors using the factor theorem. So maksud dia yang tadi tu, asalnya kita cuma ada dua factor sahaja, which is this one, two factors. Then dia kata it is necessary, perlu untuk kamu find another two linear factors untuk selesaikan yang ini. Okay, now we come to the complex zero of a polynomial. So you have learned complex number in chapter 3, if I'm not mistaken. Is it chapter 3 or chapter 2? Okay, complex zero of a polynomial. So if a plus bi, kalau complex number, we have ada I kan, imaginary kan, real and imaginary. So a ni is real part, bi is your imaginary part. If a plus bi is a zero of polynomial, then its conjugate, apa tu conjugate? Conjugate meaning, kalau dekat sini tambah, the conjugate will be tolak, will be minus. Minus a minus bi is also a zero of bx. Okay, so senang cerita lah. Kalau dia kata untuk complex zeros, kalau a plus bi ni dia punya zero, meaning the conjugate a minus bi is also a zero for the polynomial. Therefore, complex zeros of a polynomial with real coefficient occur in conjugate pairs. So dia kata untuk complex zeros, dia berlaku dalam conjugate pair, ada pasangan dia. Example, given one of the zeros adalah, given one of the zeros of this polynomial is 1 minus I. Find the other zeros. Dia dah beritahu, this is one of the zero. So you need to find the other zero. So konsep untuk complex number, dia kata tadi, kalau ini sudah dia punya zero, maksudnya dia punya conjugate dia pun akan jadi zero dia juga. So meaning that 1 plus I will be your zero as well. So let px is this one, given 1 plus I is a zero, hence 1 minus I is also a zero. Okay. So a quadratic expression can be met from complex roots given. So macam mana kita mau bentuk quadratic expression? Kita dah ada this one, kita dah ada this one, two zeros. Okay. So from these two zero, you're going to find sum of root, SOR and POR, the product of roots. Ni macam you refer back to your chapter quadratic equation. How to find the sum of root, how to find the product of root. So you have sum of root, you buatlah hasil tambah the two roots just now. 1 plus I tambah 1 minus I. The other one, product of roots, you have to multiply both of the roots. Okay. So this follow chapter 2 punya chapter quadratic equation punya formula. So you expand this one x square and this one you solve for this one, so you get 2x, and this one bila you multiply I times I, you get I square, right? So this I square is actually equal to negative 1. Remember? The imaginary part I square is actually equal to negative 1. Okay, so that's why it's become over here, it's become negative 1. Negative 1. 1 minus negative 1. That's why it become 1 plus 1 lah. At the end, bila you solve for this, you get x square minus 2x plus 2. So, why did I actually need to find this one is because I need to, since we have cubic, kan dekat sini kuasa 3, so I need to find the other roots. So, I need to find 3 roots, 3 factor. But now I only have 2. 1, 2. You need to find another one. 1, this is 1, this is 2. But since this is 3, you're going to find 3 roots, 3 zeros, and 3 factors. Factors lah. Okay. But now you only have 2. So from here, I'm going to do long division. Saya bahagilah this one, the polynomial just now I have, with this x square minus blah 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 ni lah. So I perform this long division. Okay, I hope you already mastered the long division. Okay. And then when I perform, I have this one as qx, my qx, this is my d, and this is my remainder 0. My remainder equals to 0. So again, I write it down nicely. Px equal to q times d. This is d kan? Susun semula dalam px equal to qx times dx plus r, where my r equal to 0. Plus 0. Okay. So in here, I will have my x square minus 2x plus 2. This one you can square minus 2x plus 2. Ni you boleh factorize there. So when you factorize, you will have 1 plus I and 1 minus I. Okay. So 1 yang ini, you have another one from here. The other 2 lagi dekat sini. The other 2 roots, so the other 2 factor, the other 2 0 is coming from here. So you will have the 0 is x equal to -1. And this one, if you factorize, you will have the 0, 1 plus I and 1 minus I. That's it. Okay, now let's see how the example on how to solve 3 unknown. 3 unknown lah yang kita tidak ketahui, iaitu x, y, and z. Okay, first one, let's, for now we have 3 equations. So we have 3 unknown, x, y, and z. Okay, so we have 3x plus 2y plus z equal to 9, first equation, and then this one, second equation, and this one become your third equation. So how I'm going to solve this one, we need to find what is x, what is y, what is your z over here. Okay, so first you can minus 1, minus 2. Okay, or you can minus whichever you want. 1 minus 3 also can, 2 minus 3 also can, it's up to you. But to just to get it lebih senang, I just minus 1 minus 2. Okay, 1 minus 2 over here, so I get this one. So this becomes my fourth equation. So now I multiply 3 times 2. This one I multiply 3 times 2. Sorry, 3 multiply the second equation with 3. Kenapa I multiply with 3? So that I have, because this one I only have single x, I want it to become 3. Okay, so I get 3x plus 3y plus 3z equal to 15. Yang ni tadi I kali dengan I multiply it with 3. Multiply it with 3. So I get fifth equation. Equation yang kelima. And then this is equation yang ketiga. So why don't I minus 5 minus 3? 5, equation 5 ni I minus lah dengan equation 3. So I get, bila kita tolak 3x minus 2x, you get x. 3y minus 4y, you get negative y. 3z minus 3z, nil. 15 minus 16, you get negative 1. So this become 6th equation. And since you already have these two, yang ada x, ada y, you remember this one you also have ada x, ada y. So why don't you solve for these two? Dia ada 2 term sahaja. So we solve for this one. Whether you want to plus or minus lah, whichever yang easier so that we can cancel out one of this term. So in order to cancel over here, I have y and y. To cancel this y, I want to plus add these two. Kalau saya tambah dua ni, if I add these two, then I will cancel off the y. So I will only have x plus 2x, I will have 3x. Negative 1 plus 4, I will have 3. So my x equal to 1. So done with x, I already found my x equal to 1. So how about the y and z? Okay. So now from equation 4, I can substitute the value of x equal to 1. So substitute ganti masuklah dalam, not necessarily ganti masuk dalam 4. You can also substitute into 1. Okay. So I just substitute back to 4. 2 kali 2x plus y. Where my x I already know it's actually equal to 1. Kan? So I finally found my y, which is equal to 2. And the same things go for how to find my z. From equation 2 just now over here, I already have my x equal to 1. I already have my y equal to 2. So I just substitute into this thing, this equation, to find my z. Okay, you can substitute it into whichever equation you want. But to be easy, to make it quick, you choose the one with single coefficient. Macam ni kan senang, dia ada x, y, and z saja. Instead of you substituting this into this, ni ada coefficient pula. Nanti you kena multiply 2x, 4y, 3z. Lagi susah. So ambil yang simple-simple macam ni. So you get z equal to 2. So this is how you solve your simultaneous equation with 3 unknowns. Ada 3 unknowns, x, y, and z. And a bit more advanced, you can also solve for up to 4 unknowns. Ada 4 unknowns, a, b, c, and d. Kalau tadi x, y, and z, now you have a, b, c, and d. So you have all these 4 equations. The procedure is quite similar with just now. So for example here, equation 1 minus equation 2. So I obtain this one. So this become my 5th equation. And I can also equation 1 minus equation 3. So I obtain 6th equation. And equation 1 minus 4. So I obtain 7th equation. And 2 times 5. 2 equation 2, I multiply, equation 5, just now this is equation 5, I multiply it with 2, so I get this one. So this become 8th equation, okay? So it's getting tedious, it's getting more complicated. As you go, you will have more equations. But don't worry, that new equations you are generating is actually going to help you to cancel off or to obtain the unknown one by one. Okay, so sampai dah, don't worry, up until you can get up until 8, 9, and 10 equation. So this is 8 equation already. So you can equation 7 you can minus with equation 8. 7 ni boleh tolak dengan 8 because they ada similar term. Ada A, ni pun ada B, ni pun ada C. So tolak je lah yang dua ni. Okay. So I obtain this new equation. So it become equation 9. And equation, this one, 2AC. 2A plus C. So I multiply it with 4. 4 times equation 6. So I get this one. Okay. So boleh lah. I will buat 9. Equation 9 plus 10. So I obtain this one. 9 plus 10. Just to cancel off one of these lah. So I get A. Ni dah 4. 4C. This one pun dah 4C. Dah cancel out. So yang tinggal 8A minus 3A. So you get 5A equal to 10. A equal to 2. So this A equal to 2. You can substitute into ke dalam ni, or you can substitute into this one also can. then you will get C equal to 4. Okay, since you already have A and C, you can pick any equation from here. You plug in the value A and C. For example, this one I use equation 7, but you can also use equation 8, 6, 5, or whichever equation. You substitute the value of A and C, then you will get your B. So dah dapat 3. You have A, B, and C. Okay, since you already have A, B, and C, let's say, now I pick the equation 3. Because equation 3 dia semua ada single. 1A, 1B, 1C, 1D equal to 10. So I substitute all the value A, B, C I already have just now to find my D. So finally I have my D equal to 1. Okay, so this is how you solve 4 equation. You solve simultaneous equation with 4 unknown. Okay, I think that's all.